Hi, welcome to my channel, JaberTime. Today I have an example for you for quadratic functions in standard form. I do have the graph, the equation, the X-intercepts, the Y-intercept, the axis of symmetry, the vertex, and another point on the other side of the line of symmetry. Let's get started. So we have y equals x to the second plus 4x plus 3. And I have the graph here to support all the information that's going to be displayed. First of all, to find the y-intercept, usually it's the c value. Why? Because you plug in 0 for x. To find the y-intercept, you set x equals 0 to be on the y-axis. This cancels, the only thing stays with you is 3, and usually it's the c value. We have it 0, 3 right there. If a equals 1 from here, that means the graph opens up because it's positive. And we could see that the graph opens up. What about the axis of symmetry? To find the axis of symmetry, you need to take minus b over 2a, and that's going to give you the value for x. The dashed line right there. We have minus b over 2a minus 4, because b is 4, over twice a, where a is 1, minus 4 over 2, which is negative 2. And that is true right there. It's at x equals negative 2. Let's look for the vertex. Once you find the x component of the vertex, which comes from the axis of symmetry, you plug in that value, which is negative 2, into the equation f of negative 2, and you end up with negative 1. I'll leave the steps for you. I'm not going to read all the steps, but it's already displayed to show you where I got the minus 1 from. So the vertex is negative 2, negative 1. Which means we have a minimum at x equals negative 2. The graph supports that, and since the graph opens up, we do have a minimum. And the minimum value is the y value, which is negative 1. This right here. To look for the x-intercepts, we factor it if we can. If we can't, we use the quadratic formula. This one is factorable, which is x plus 1 times x plus 3. Setting this whole thing, or y equals to 0, we end up with x equals negative 1 and x equals negative 3. And those are negative 1 and negative 3, the x-intercepts. How do you find the y-intercept? To find the y-intercept, you set x equals 0, as we did before, if you want to do it in steps, or you take it from the c value. Now, once you have the y-intercept and you have the line of symmetry, same distance, you go to the other side because of symmetry, because the axis of symmetry, or it's called axis of symmetry, which means any point on this side from the line of symmetry or axis of symmetry will have a reflection on the other side with the same distance. So if this is at 0, 3, and the line of symmetry is at x equals negative 2, I should go all the way to negative 4, same height, which is 3. So another point on the graph would be negative 4, 3. That should do it for this example. It's about 4 minutes and a half, and that should do it. Thank you. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.